Hello there, 8th graders. This is Teacher Krishna, and welcome to our science class for week number 20. It's great having you all here because I know that you're doing a great effort. Trust me that all the community in Beehive really appreciates your effort a lot. So let's keep it up, guys. Before we start, just like every week, log into Agilix, enter to the Google Classroom, download the Word document from a Google Classroom, and save it inside your science folders just like it is specified right below. Alright, and as we move, remember to take notes on the Word document. That is extremely important so you can keep track of the most essential things from this topic. Little observation. This topic is one that we studied already, but we are going to review it and I'm going to expand it with some information. So only add some extra information to the summary that you previously had. The ending mind for today is the following. The students will be able to review topic 3.03 to retake the evaluation of this topic in order to improve their overall average. So, today we're going to re-study the topic, then you are going to retake the evaluation, and of course you can improve a little bit your average in Agilix. Alright, so we need to have a very small review. So please go to the first post in Google Classroom and review the content from the presentation that you have right there. Okay, so and just go ahead, read it a little bit, and once you have refreshed your mind already, please come back here and we're going to add some extra information to the one that is right over there. Alright, so right now we're going to talk about oxygen and of course how it relates to indicators of water quality. So in Agilix you found a big table with water quality content that you had to read in the class where you were learning about this topic. But today we're going to discuss it a little bit and have some more information about it right over here. So we're going to start by talking about the dissolved oxygen and how it relates to water quality. So it is the amount of oxygen that you can find in water. And usually plants are the ones that release oxygen. Sometimes plants are going to release it directly to their environment, like directly to the air, but some other times the roots of some plants are going to release some oxygen as well. So of course that is going to change the amount of oxygen that you will be able to find in the water. And it has almost no effect in the human body, so it doesn't really matter if you find a portion of water with a little bit more oxygen than it should have. So there is no effect at all in there. But there is something interesting that happens with the lack of oxygen, and it can cause the death of living species. You have to remember that in rivers, lakes, and in the ocean, there are several living species such as fish. And they need oxygen in the water in order to breathe and, of course, survive. So if the amount of oxygen that is found in water decreases too much, many living species can die. And the appropriate level can be between 15 milligrams per liter and 6 milligrams per liter. Notice that when you have colder temperatures, the amount of oxygen that you find in water will be higher. So in cold temperatures, the average amount of oxygen is going to be in 15 milligrams per liter. While when water heats up, the amount of oxygen that it has is going to decrease. So in hot water, it will be normal to find an amount of oxygen of 6 milligrams per liter. Alright, now we're going to talk about the indicators of water quality related to fecal coliform. So, fecal coliform is basically like excrement that you might be able to find in some portions of water. And where can this come from? It can come, of course, from all of the water waste from people in different towns. So, feces in the water are basically excrement, just like I was mentioning. It may come from runoff or septic tanks. So runoff will be like the normal or the natural way of finding feces in the water, because you know that there are a lot of animals in the wild, and after their excrements are in contact with runoff, then they are going to be taken to the rivers or lakes, depending on what we're talking about. But the septic tanks are the places in which humans storage all of the water waste that comes from the houses. So all of the waste of water that you have at home are going to be ending up in a septic tanks, like the water that you use to wash the dishes, or the one that is used in the restroom, or when you take a shower as well. That will be part of the water waste from your home. And water can contain bacteria and dangerous viruses for humans. What happens is that excrements are something that actually impulse the generation of bacteria and virus in water. So, if at some point humans drink that water with feces in it, what is going to happen is that we are going to get very sick because it contains bacteria and viruses that are not healthy for our body. It causes water to have less oxygen. And remember that if we have less oxygen, it means that some living species in the water can die. Drinking water should have below 1 colony per liter. So 1 colony per liter is basically nothing. Like drinkable water should not have any feces in it, because one more time, it can contain viruses or bacteria that can be very harmful for the human body. And rivers and lakes should have below 100 colonies per liter. Even though there are 100 colonies, it's still a very little amount of feces in it. And it's something that we cannot actually control because it's part of the natural world. Alright, now this is very interesting to analyze as well, the pH scale. So we have to start by explaining that the neutral pH is right at number 7. And just like you can see right there, there is a bottle of water in number 7, which means that that is the ideal pH that water should have. If it goes below 7, then the substance is going to start turning acid. And if it goes below, or most likely it goes above the neutral pH, the substance is going to turn alkaline. So let's analyze a little bit more about it. pH scale. It measures the acidity or alkalinity of a substance. Remember, the neutral one is number 7. Acidic depositions in materials like limestone can change the pH in water. So, acidic depositions can come one more time from a human activity, from a certain industry. And limestone is an element that is mostly found in nature. So if the water goes by a place where there is limestone, then it can change the pH scale in the water. Drinking water must have a pH of 7, and rainwater has a pH of around 5.6. So that is why we do not really recommend to drink water that comes from the rain, because in order to have like pure water, we need to change a couple of things besides just the pH. Right, and a high acidity or alkalinity can kill living organisms. Yeah. So, for example, the acid that you can find in a battery, that is extremely harmful, because if it even has a very small contact with your skin, it can burn it. So imagine if you drink it, of course, it's way possible that it's going to be very harmful, or that it can even kill you. And the same thing happens if a material is way too alkaline. It can be very dangerous for a living species. And for animals and plants, the pH must be in between 5.6 and 8. So these are like the standards for the pH in the water, for, of course, being able to drink it. But the best one will be, one more time, a straight 7. And now we're going to talk about the temperature. So it is measured in degrees Celsius. In the nature, the temperature of water is regulated by sunlight and surrounding land. So one more time, these are the natural ways in which temperature is regulated. So just from the sun that comes from the land, and of course, depending on the weather conditions in the part we're analyzing water from, then its temperature is going to change. High temperatures decrease the amount of oxygen in water, which can cause the death of organisms. Yeah, just reviewing what I mentioned in a previous part of this presentation. High temperature will be interpreted as a lower portion of oxygen in the water. While you have lower temperatures in water, it will be translated into more oxygen in that substance. The ideal temperature for organisms depends on what necessities it may have. So the ideal temperature in water for organisms can depend a lot, and it may vary depending on the species that we are talking about. So, for example, if we talk about golden fish, the water does not have to be way too hot or way too cold. So it has to be at a normal temperature so it can survive in the water. Right, and the last thing that we are going to analyze related to water quality will be the turbidity, or turbidity, I'm sorry. So turbidity is basically how much materials are suspended in the water. So if you have a low turbidity, you are going to notice that the water is transparent, basically. But if it has a high turbidity, it's going to be like brownish, so it will have a different color. So turbidity is the amount of suspended material in water, and drinking water is constantly monitored regarding turbidity, its taste, and other changes with higher turbidity. Yeah, for example, if there is a high amount of feces, just like in one of the examples we were seeing before, of course, the water is going to have a brownish color, the other is going to be terrible, and of course, you are not going to want to drink that water. What we're looking for is for it to look absolutely transparent with no materials in it. A very high turbidity does not allow sunlight to penetrate through it. Therefore, water plants cannot grow. Yeah, so it's very important that there is a high turbidity in water because it can cause the death of several organisms. And standards for drinking water should have a very low turbidity. Right? So now, let's have a small reflection. So, you in your house use a lot of water for doing the dishes, for taking a shower, for going to the restroom, absolutely everything. So, what process does the water need to follow in order to be purified and in order for us to use it one more time? So, that is why we're going to be analyzing the process of water disinfection at water treatment plants. So, number one will be houses and business. And from there, sewer conveyance systems gather wastewater. So all of the wastewater that you have at home will be put all together and it will be redirected to a treatment plant. Then we have a pump, which is when water is taken to a water treatment plant. Step number 3, grid screening, which means that water slows down and large particles settle down. So when water reaches the water treatment plants, its speed is going to decrease. So all of the large particles are going to start coming to the ground. Number 4, primary clarifiers. The solids sink and other materials such as grease, fats, and oil rise to be removed. Yes, so since it slows down, all of the solids are going to come down thanks to gravity. And then with a special machine or with the use of some other artifacts, all of the grease, fats, and things that rise up from water are going to be removed. Number 5, aeration bases. So aerobic bacteria and protist organisms consume organic material. So like microorganisms are going to start eating all of the organic material, so then it can be cleaned up. Then we have the filtration, which is when water can be pumped through sand to remove some remaining particles. And this is the last step, And after this step, we're going to have water that is going to be used one more time by humans, which is the process of disinfection, in which water is treated with chlorine, ultraviolet light, or ozonation to disinfect it. So after that, there are no solid materials, there is not turbidity at all, and of course there are not microorganisms that can affect or harm our body. Okay guys, so now we're going to go with the regular evaluation and the honors evaluation. So the regular evaluation is read and study topic 3.03 and then take the quiz for topic 3.03. Then the honors evaluation is the following. Create a report in which you include the way all the content from this topic relates to the Guatemalan context. Include specific examples and regions. So you have to do some research about the process in which all of the water from water waste is treated, what treatment plants we have in Guatemala, and how it comes back to our houses again. Of course, we have to answer the following question as well. Do you consider that the processes of our country are functional regarding water purification and disinfection? Write a critical comment. So today, only one student has to complete the honors evaluation, which is Elena de Leon. So only Elena complete the honors evaluation, and the rest of students, you have to complete the regular evaluation. Although there is another option. Remember, this honors evaluation is something that you can take as an optional resource for expanding your knowledge. So if you are feeling confident about your knowledge of the topic and you would like to take the honors evaluation, you can just let me know and you can go ahead and do it, okay? One more time. Remember, only Elena de Leon has to complete the honors evaluation. The rest of the class has to complete the regular evaluation. But if you're willing to expand your knowledge and learn a little bit more, you can always contact me. So I wish you the best of luck, guys, and I will be meeting you during the Zoom session in a couple of minutes. Goodbye.